Good afternoon, everyone. I am Dr. Suchi Tiwari, Department of Chemistry, VNR VJIT, Hyderabad. Today, I'll discuss the topic that is called infrared spectroscopy, their application part. In the application, we can find out the night vision and carbon monoxide detection. So, how it will be coming in this infrared spectroscopy? If we know in the dark, if everything is dark, it is difficult to visible for the human eyes. So for that reason, if anything is in dark and we are not able to visible, we have to be use this technique that is called the infrared spectroscopy. For that, I am giving the talk for today slide. How we can see this invisible? What will be happen in what is the principle involved in this infrared spectroscopy? That we can see if you seeing in this slide. You seeing there is a one in the one area. There's a dark. That is we are saying nothing can be seen with our normal eyes. But when we have to be detect with the infrared vision, we are able to detect it. The reason is that in the infrared spectroscopy, we are not using any light. We are using the thermal efficiency, thermal radiation. So that's the reason this thermal radiation we are able to visible. When the whatever the darkness will be there, thermal impression will be low. If the darkness is less, thermal impression will be high. So that way we are able to see this infrared spectroscopy. So today our learning objectives are there. First, we understand what is infrared spectroscopy, how it will be discovered, what the radiations are there. Then we have to be going for what type of the vibrations and what type of the bending and stretchings are there. After making these foundations, then we have to be going their application, explore what is the night vision, how we can use this infrared spectroscopy in the night vision, and we also detect the mainly harmful gas carbon monoxide. So these two examples we can find out in this talk. So what is the foundation of the IR spectroscopy? So IR spectroscopy, if we are saying, we know the visible range, that is called the VJEC. It means violet to red. So when the violet will be there, if the part of that, then it is called the ultraviolet. When the after red, then it is going from the infrared spectroscopy. Infrared spectroscopy is generally it is coming from the 700 nanometer to 1 nanometer. And it will be divided from the three regions that is called the near IR, mid IR, far IR. For that, we have to be finding this is the infrared spectroscopy. This zone is called the infrared spectroscopy. From the normal human eyes, we are not able to visible, but with the some other thing, with the thermal impression, we are able to visible for this slides. So there is a two type of the vision we have to find out in the infrared spectroscopy. First is active vision and second one is called the passive thermal imaging. So detailing we can go from the later slides. Why this IR matters? What is the use? Why it is very much important for us? Yes, it is a very much important and we are using in our day-to-day life. Very first, CCTV camera, I think everyone is very much familiar about that one. This CCTV camera is based upon the active IR in spectroscopy. Then we have to be, if any accidents are happen, especially from the fire accidents are happen, these fire accidents we have to be seeing there a lot of smoke and all these things. Visibility is, it is not there, visibility will be zero. That time also this infrared spectroscopy, it will be useful. And the another thing, when the visibility is not required, the gas which is a colorless and odorless, that time also we are able to use it this spectroscopy, and we can find out, we can save the life, we can save the environment, and we can protect our life also. That's the reason it will be much important. So what are the core objectives of this talk? The very first, the principle, what are the fundamental physics of the infrared spectroscopy, what is the molecular absorption will be going on, that we have to be seeing in this one. Then we have to be check first application night vision, how this thermal emission are thermal emission is converted into the images, and we are able to see from the even the dark even to darkness also. And the third one is going from the carbon monoxide detection, because we know from the transportation and everywhere, carbon monoxide is one of the most toxic gas. And after later we can integrate this technology, how we can integrate with our AI or from the whatever the AI and AIML or IoT networks, all the whatever the modern technology, how we can incorporate this modern technology with this IR spectroscopy. So this is the IR spectrum. If you're seeing that one, visible light, it will be going from the VIGNANA to visibility will be there. If you are taking about the 0.7 micron to 1000 micron, then it will be giving the, this is called the infrared zone or infrared spectrum. Here we have to find out this infrared spectrum is mainly based upon, mainly visibility is given from the thermal radiations. So how these thermal radiations are working? These thermal radiations are working with the whatever the thermal energy we have. We know every object, whatever the materials are there, they have the some certain amount of the thermal energy. That thermal energy always radiated, and this radiation IR spectroscopies catch, and they will this radiation they can catch in the form of heat, and then it will be converted into the images. With the technology we are able to convert it into the images. So what are the reasons of the near, mid and far infrared spectroscopy? Very first, if we are going from the wavelength, it will be coming from 0.78 to 2.5 micrometer. This is called the near infrared spectroscopy. And then it's coming from mid infrared spectroscopy or mid infrared zone, that is called the 2.5 to 25 micrometer. And then the far infrared, it will be coming from the 25 to 1000 micrometer. So characteristics, how we can going for that one. So from that, generally IR spectrum or IR radiations giving the vibrations. In the vibrations, there are huge, so many vibrations are there. Then we have to be combined with that one. So generally in the near infrared spectroscopy, we have to seeing their overtones and the combinations of the vibrations. And the mid infrared spectroscopy, that is the main zone, that is called the fingerprint region. And there we have to find out the all functional groups what are present in the any type of the material that contains the characteristics absorption. For example, alcohol, amine, or maybe carbonyl groups, all these are coming in this zone. Then it's coming from the far infrared spectroscopy. It is a lower energy vibrations, and generally it is from the some lattice or some crystal type of the structures or crystal metalling part. It will be find out from this far infrared spectroscopy. What are their major applications? So generally in near infrared spectroscopy, we have to going from the agriculture side, agriculture, so many images and all these things, food quality analysis, pharmaceutical industries, fiber optics communication, there we have to be using. And the mid infrared spectroscopy, mostly it is called the Fourier transform spectroscopy, molecular identifications, chemical analysis, there we are using. And the far infrared spectroscopy we are using for the thermal imaging, astronomy and the material science we are able to use it. So that will be coming from the 3 zone. There are the different variety of the applications are there. So what will happen in this IR spectroscopy? I already said it is a vibration. So in the vibration is going from the 2 type. It is first is called the stretching mode, and second one is called the bending mode. Because it is the only application part, so we are not too much going what are the modes are there, what are the detailing are there. But you have to know when the stretching will be there, there is some peaks are generated. When the bendings are there, some peaks are generated. So this is the instrument for that from the IR system. So very first, that is a IR source. Definitely if the system will be there, we have to require the source, that IR source. Then it will be collecting from the sample chamber. There is a sample chamber will be there. In the sample chamber, there's so many that rays are going, and there's going from there so many bending and stretching will be there. After this bending and stretching, that they are detecting. After detection, they will putting the signal process. They are going from the signal processor, and the signal processor they are providing the certain type of the images. Every molecule or every atom, anything, it will be the unique structure, unique vibrations will be there. There is a not common vibrations will be happen. So if you are seeing one IR spectra, if you are seeing from that IR spectra, so there is from the spectrum we have to find out the different type of the identifications. For example, if you are taking the OH, that will be giving the some broad spectrum. So the peak will be coming a little bit broad. If you are taking from the some other CH stretching, so that will give the little bit the fine or sharp peak. If you're going from the carbonyl groups, because the carbonyl is one of the important from the organic compound, they are giving the little different type of the stretching sharp peak and very strong peak. And another, there is different peaks are coming. Many peaks are coming that are not required for the identification. Sometimes it will be noise is also there, and some type of the impurities are there. Those peaks are is required for the identifications. That should be required the very sharp, and that should be required the very prominent peaks, that only we can able to identify the things. And we are plotting the graph, or we are taking the graph that is the transmittance and the wavelength. Wave numbers we are taking from the x-axis, and the transmittance we can take it from the y-axis. Transmittance generally we are taking in the terms of percentage or the absorbance. So this is the one example I take how this, if you're taking our finger or anything, whatever the radiations, whatever heat we are reducing, that heat will be combining with the IRs, and then they will collect their heat and they generate the our signature. They are generating from the that impression of in the forms of peak. So these are the three examples. In the fire rescue, we are using in the defense area. We are using because defense, so many activities are going in the dark only. And the smartphone, smart home, we have to using a lot of remote controls and all these things. So that will be coming from the smart home. So these are the major applications that we are using. And that is a positive point of this IR spectroscopy. It will be whatever the visuals or whatever the obstructions are there, that will be not affecting the thermal consult when the radiations is going on, because it's look the temperature differences. That is the reason this IR spectroscopy is the more important. How this thermal camera works? First they will take the thermal waves, then it will be going from the optical lens, then it will be going from the microvoltmeter arrays, and then this microvoltmeter arrays, they will collecting the electronic signal and the false color mappings also. And after that, this color mappings, we are getting the images in the form of colors. If the complete light will be there, images are in the color. If the lights are not there, images are coming, generally images are coming in the black and white. So this is the way of the translating heat into the site. From the human body, we know our temperature is at 37 degrees centigrade, and what is the principle will be there, we already know. Till now, you know whatever thermal imagings are there. Every object in universe have the absolute zero natural emit radiations are there. Night vision technology does not look light; it's look like temperature. By detecting the varying level of the thermal radiations, sensors can differentiate human, animal, and object signature in the pitch of darkness. So only that is the things are there, thermal radiations. What are the temperature will be there? What are the things will be there? That way we are able to find out. And it will be going from the absolute 0 to 1000 degrees centigrade temperature also, maybe the. So from the engineering side, we have to be going from the two type of the system. First we are saying active IR system, and second one we are saying passive IR system. Active IR system, we can detect and reflect the IRs. Here in the passive, we can detect the natural thermal emission. Only the natural thermal emissions are there. Here is the IR illuminator plus camera will be there. But in the passive, the work is going from the microbolometers. It is a high contrast and a gray scale images are there. It is a thermographing in the false colors are there in the passive. And it will be generally we are using active IR system in the short range securities like CCTV. But in the passive IR system, generally we are using the military surveillance and the smoke rescue. So it means that when the disaster, some accidents are happen, mostly we are using the passive IR. When in our home or anywhere when the CCTV cameras are there, they are using from the active IR system. So we are going from the one example that is called the carbon monoxide. And carbon monoxide, we know it is also called the silent killer. It is a colorless as well as the odorless and highly toxic gas. And we know in our transportation, whatever the vehicles are there, they are continuously continuously radiation with this carbon monoxide gas. So how we detect in this IR? So in this IR system, we already know it will be giving the particular peak. So in the carbon monoxide, it will absorb the radiation that is called the 4.6 micrometer wavelength. So that is the reason we can see if the carbon monoxide, our IR sensor will be there. So it will immediately catch this gas, that particular zone, and it will be what then we are able to find out there is a carbon monoxide will be there, and it will be intensity will be decided how much amount of the carbon monoxide will be present in that particular environment. So this carbon monoxide, if you're seeing that one, I already said it is in the transport. So mostly we are using from the PUC vehicle emission sensors. They are making the sensors like that. So we are putting the infrared source, then the same gas chamber will be there, then the optical filters and detectors will be there, and after that optical filters and detectors, then it's going from the signal processor. And then after completing the signal processor, then we are able to find out how much amount of the carbon monoxide present in the environment, or maybe how much carbon monoxide will be emitted that particular vehicle. This is the anatomy in little bit more detail. IR source will be there, that is the emission of the heat and the filaments, and then there is a chamber there that the gases, the carbon monoxide gas or other gas, it will be absorbed. If the carbon monoxide, if we are going from the carbon monoxide, so that will be absorbed from the 4.6 micrometer, then it will be going from the optical filters. After that, it will be intensity will be reduced and given a signal, and then we have to go from the processing, we can detect, and after that the processing, that processing will be giving the how much amount of the CO concentration will be there, that we can convert it with the some mathematical calculations with the software. This is a real world example. Most of the whatever the vehicles are there, they are putting in this NDIR sensors from the critical infrastructure to the global vehicle emission testings, and they provide the rapid non-conduct measurement of the toxic exhaust before it's entering the atmosphere. So infrared spectroscopy, not only two applications, it will be giving the lot of things. It is protecting the life. Thermal contrast imagings are there, night vision, surveillance will be there, fire rescue we can go, and it's also safeguarding the environment. If we identify how much toxic gases, order-led toxic gases we identify, then we are trying to reduce that one. So it will be also supporting safeguarding the environment. So infrared spectroscopy is working not only from the chemistry, it is the combination of electrical engineering, software processing, then only this final product will be coming for the society benefit. So if you're going from the future, we maybe this infrared spectroscopy detect with the AI integrations, we can put the IoT dashboard, we can put the wearable HUD. Already we are knowing so many areas they are using these things, and but still these applications are limited. We have to be going from the more and more limited as well as the costly. We have to make it is from the economic point of view also. So this is after completing this one, we have to find out what are the wavelength range of this spectroscopy. I hope everyone is understand that is the 0.7 micrometer to 1000 micrometer. What is the active and what is the passive? How we can find out what is active IR, what is the passive IR? What is the carbon monoxide absorption band? That we know it is a 4.6 micrometer, and how we can incorporate from the PUC, or maybe from the vehicle emission, whatever the carbon monoxide gas will be there. Thank you for watching and listening and being the part of this journey. Infrared spectroscopy help us to unseen detect the invisible and protect what matters. Same thing will happen with the happiness. Invisible of the eyes, felt in the heart, spread the smile and create the better world. So if you think science make life safer, happiness make life better, together let's build a safer, healthier and happier world. Thank you so much. If you found this videos helpful, please like, share and subscribe to support more such contents.